All right, class, section 7.1, apply the Pythagorean theorem. Now, I will make separate 7.1 and 7.2 videos, but the homework will be combined, both sections combined into one homework. So make sure you watch both 7.1 and 7.2 before jumping into the homework. All right, for 7.1, it's applying the Pythagorean theorem. You're going to use the Pythagorean theorem to find side lengths of a right triangle. It only works with right triangles. So the hypotenuse is the side opposite the right angle. So opposite the right angle. And it's very important to identify which is the hypotenuse before substituting in values for the Pythagorean theorem. Either leg can be A or B, but the hypotenuse must be C. What I'm talking about with A and B and C is the Pythagorean theorem is in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And that's represented as C squared equals A squared plus B squared, or you may hear it as A squared plus B squared equals C squared. It can be written either way, referenced either way. But that C value is always the value of the hypotenuse. A and B are either of the legs. Skipped over our first page. Here we go. We need to find the value of x and write our answer in simplest radical form. So in our first triangle, and we can see all of these are right triangles, so we can use the Pythagorean theorem with them. We have two of our legs, and x is the hypotenuse. Notice our hypotenuse is opposite the right angle. So we would say 6 squared plus 8 squared equals x squared. Or x squared equals 8 squared plus 6 squared. Now the order of our 6 squared and 8 squared, that doesn't matter. It could be 8 squared plus 6 squared. That's still the same thing. So it doesn't have to be smallest first, it could be largest first. So 6 squared is 36, plus 8 squared, which is 64, still equal to x squared, or c squared if we kept it as a, b's, and c's. So then 36 and 64 gives us 100. Now 100 equals x squared. It doesn't equal x. So to find the value of x, we need to square root both sides. So I would say the square root of 100 equals the square root of x squared, which is x equals 10. So our hypotenuse, x, is 10. For our next one, our missing side is one of our legs. So those are our legs. 17 is our hypotenuse. Also notice the hypotenuse is always the longest side. So you can see 17, or we do know 17 is going to be longer than x, our missing value. So if we get anything bigger than 17, we know we've done something wrong. 17 is our hypotenuse. So here we have 8 squared plus x squared equals 17 squared. 8 squared is 64 plus x squared. And then 17 squared is 200 and 89. So from here, we want to get x by itself. So we'll subtract 64 from 289. And that is 225. And again, x squared, or x does not equal 225. X squared equals 225. So we need to do the square root of both. And the square root of 225, if you use your simplifying radicals sheet on the front to check those perfect squares, is 15. So x is 15. 15 is indeed shorter than 17. So I know that fits. That could be a possible answer. But if I stopped at 225, that should be a red flag because 225 is a lot longer than 17. So looking at our next example, our x is one of our legs again. So we will have square root of 7 squared plus x squared equals square root of 19 squared. Now whenever I square the square root of 7, that becomes square root of 49, which is just 7, plus x squared. And then whenever I square the square root of 19, it is just 19. So to get x squared by itself, I'll subtract 7. X squared equals 12. Again, that's not our answer yet. We need to square root both sides. Find the square root of x squared and the square root of 12. Square root of x squared is just x, but the square root of 12 is going to simplify. 12 is not a perfect square, so this is one that we have to simplify, like our simplifying radicals practice. So that simplifies to square root of 4 times the square root of 3, which is 2 square root of 3. So x is 2 square root of 3. All right, in this example, we have a picture of a ladder leaning up against a house. We're told it's a 16-foot ladder, and it's resting against the side of this house. The base of the ladder is 4 feet away from the house. And so we need to find out approximately how high above the ground is the top of the ladder. So we're going to represent that by x. We can see that that's one of our legs because 16 would be our hypotenuse. 16 is opposite, the side opposite the right angle, the side that does not touch the right angle. So it's going to be one of our legs. So it could be our A or our B. So I can say 4 squared plus x squared equals 16 squared. 4 squared is 16, x squared stays the same, and 16 squared is 256. We can subtract 16 from both sides. Gives me x squared equals 240. Then we need to square root both sides. Square root of 240. Since our question did say approximately, that means we can use some decimals here. So we don't need to simplify square root of 240. We can punch this straight into our calculator since it says approximately. So if you punch in the square root of 240, we will get Let me get our exact decimals. We get 15.49193338. And there's probably a bunch of numbers after that also. So to approximate that, we would round our decimals. So round to the nearest decimal place. Maybe a question asks you to round to 2 decimal places. But this one we can round to 1. So 15.49 rounds to 15.5. So we can say that our ladder is, and to show it's approximate, it doesn't equal 2 squiggle lines like those similar squiggles, means approximately. That's approximately 15.5 feet. Don't forget to label. All right, this example, we want to find the area of an isosceles triangle. And our triangle has side lengths of 16 feet, 17 feet, and 17 feet. That is this. Down here is 16, 8 and 8 added together. So we've got our sketch already. But in an isosceles triangle, the altitude to the base is also a perpendicular bisector. So notice where h, our height, that's our altitude. It is bisecting that bottom side. That bottom side length is 16. That's splitting it perfectly in half. This only works with isosceles triangles. It will only be a perpendicular bisector if the triangle is isosceles. Or if you know it's a perpendicular bisector, you know the triangle is isosceles. So it is splitting that base in half into 8 feet and 8 feet. And we have 2 right triangles here. So we can use our Pythagorean theorem to find the altitude. That's a missing leg of each of our smaller triangles. So I can say 8 squared plus h squared, which is our height that we're trying to find, equals 17 squared. So 8 squared is 64, h squared stays the same, and 17 squared is 289. Subtract 64 from both sides, and h squared equals 225. Well, that's just like one of our previous examples. So when I square root both sides, I get h equals 15. So my height is 15, but what did the question ask for? It asked us to find the area. So though we now know h is 15, our height is 15, we still need to find our area. An area of a triangle is 1/2 times base times height. Area equals 1/2 times the base times the height. So in our specific triangle, we have 1/2 times a base. Our base was 16. Don't get that confused with the 2 smaller 8s. We're looking at the large triangle. So the large triangle, the base was 16. And then our height was 15. That's what we just found out. So when we multiply out this all together, 1/2 times 16 gives us 8. 8 times 15 gives us 120 feet squared. Remember, our unit of measure needs to be squared anytime we're finding the area. So it is, our area is 120 feet squared. And then our last example, if we have a ramp, say we have a shipping dock, has a mobile ramp that is used to help load and unload cargo from trucks. The ramp is 125 inches long and has a base that is 120 inches long. What is the height of the ramp? So I've drawn a picture here. We can see at the base is 120 inches and the ramp itself is placed at an incline. It's 125 inches long. We can see from the picture, now that we've drawn that out, that the ramp length is our hypotenuse. So it's going to be our c squared in the Pythagorean theorem. So I would have 120 squared plus h squared equals 125 squared. So hopefully you've got a calculator handy. So 120 squared will give us 14,400. That doesn't really look like a 4. Let's make that look more like a 4. 14,400 plus h squared equals, and then 125 squared is 15,625. Then we can subtract 14,400 on both sides. Which gives me h squared equals 1,225. Now, on your perfect square chart, it only goes up to 400 for you. So you definitely do need to punch this into the calculator, make sure it's a perfect square. In this case, it is. If it wasn't a perfect square, then I would say start with the largest of the perfect squares you know on that chart and work your way down from there, trying to divide in. But it does work, so h is 35. And since we're working with inches as our unit of measure, that's 35 inches. All right, that's it on the 7.1 notes. Remember, make sure you watch the 7.2 notes before moving on to the homework because the homework is combined together.